Day 3, Problem 1. An 18-foot ladder is leaning against a tree. Its base is 5 feet from the tree. Sketch a diagram. So I need a tree, and maybe this is my tree. And then there is a ladder leaning against the tree. So a line across here might be the ground. And then, as I've drawn before, when leaning a ladder against a wall, perhaps the ladder leans against the tree like this. And here are the rungs of the ladder. Now, the key idea to recognize here is that in math class, this creates a figure. This creates a triangle shape. And this is, in fact, a right triangle. So here is one side of the triangle. The ladder forms another side of the triangle, and across the bottom is the third side of the triangle. And right here is a 90-degree angle where the tree meets the ground. Okay. We are told that the ladder is 18 feet long. So it's the side of the triangle that is the ladder that gets labeled the 18 feet. And that the base of the tree, or the base, is 5 feet. So this side here is labeled 5 feet. Okay? So there is our diagram for part A. Now part B, use the Pythagorean theorem to find how high the ladder reaches. Now the Pythagorean theorem is a squared plus b squared equals c squared. So I'm going to start by writing that down. Now the letter A in the Pythagorean theorem is the shortest leg of the right triangle. That appears to be in this drawing, this side here with the 5 feet. So the 5 gets filled in for A. The letter B is the other leg of the right triangle. And in the drawing, that is this side here, which is how high up the tree the top of that ladder touches. And we do not know how long that is. That's what we're asked to figure out. And so I'm going to put a variable on that side of the triangle. Because it's the letter B in the Pythagorean theorem, it makes sense to use the letter B as the variable for that unknown side of the triangle. And so b squared. Now, the letter C is the hypotenuse of the right triangle. That is this diagonal looking side that is across from the 90-degree angle, and that side has 18 feet. And so the letter C can be replaced with 18 squared. And so we have the equation 5 squared plus b squared is equal to 18 squared. And we'd like to solve that for b. We want to isolate the letter b. Okay. I'm going to draw a line through the equal symbol to keep the left side separate from the right side. And on the left side of the equation, we would like to get the letter b alone. Well, here is the b term. And next to that, there has been a 5 squared, which has been added to the b term. We can remove the 5 squared using subtraction. So underneath, subtract 5 squared. And on the right side of the equation, subtract 5 squared. 5 squared subtract 5 squared makes 0. There's a 0 in this position here. And the b squared can be brought straight down. On the right side of the equation, 18 squared subtract 5 squared. We need to figure out what that is. So first of all, what is 18 squared? So 18 times 18. 8 times 8 is 64. Write the 4 and carry the 6. 1 times 8 is 8, plus 6 is 14. Start the next row with a 0. 1 times 8 is 8. And 1 times 1 is 1. And adding these results together, that's 4. 4 plus 8 is 12. Carry the 1. And 1 and 1 and 1 is 3. 324. Okay. Now, from the 18 squared, we need to subtract 5 squared. Now 5 squared is 25. So really we have to figure out what 324 subtract 25 is. And 324 subtract 24 would be 300 exactly. Subtracting 25 would be 299. So b squared is equal to 299. Now we want to solve for b, and that means we need to remove this exponent of 2. And we can do that by using square root. So the square root of b squared is equal to, and then on the right side of the equation, the square root of 299. The square root of b squared is b. And the square root of 299 is probably a decimal of some kind. We're going to have to take a guess at that decimal. Perhaps out to one decimal place, we can take a guess at about how much the square root of 299 is. Okay? So I'm going to grab a piece of scrap paper, and let's work at figuring out a good guess for the square root of 299. What does that make? Okay. Well, earlier we had figured out that 18 times 18 is 324. That's more than 299. So the square root of 299 has got to be less than 18. I'm curious, what is 17 times 17? So 17 times 17. 7 times 7 is 49. Write the 9, carry the 4. 1 times 7 is 7, plus 4 is 11. Start the next row with a 0. 1 times 7 is 7, and 1 times 1 is 1. And adding these rows together, this is 9, 8, and 2. Okay. Now, 299 is more than 289, and so our answer for the square root of 299 must be more than 17. But recall, it was less than 18. Recall that 18 times 18 was 324. And so where is 299 compared to 289 and 324? It's somewhere between there, and so our answer for the square root of 299 is going to be 17 point, and then we can take a guess at some digit to use here in the tens position. Now, 299 is 10 units greater than 289, and 299 is 25 units less than 324. So 299 is not exactly halfway between 289 and 324. If it was exactly halfway, we could use the number 5 as our decimal guess, but 299 is closer to 289. So instead of using a 5 for our tenths position, I'm going to guess and use a 3. My guess for the square root of 299 is 17.3. So returning back to the warm-up, 17.3. In our original picture, the variable b was how high up the tree that ladder reaches, and we have figured out that it is about 17.3 feet. So 17.3 feet. Now, day 3, problem 2. Part A, graph figure ABC with vertices at A and B and C. And then in part B, we're going to create the dilation of that triangle. And we're going to call this dilation A prime, B prime, and C prime. Okay? And then in part C, find the coordinates of the vertices of that new triangle. So let's tackle this one step at a time, starting with step A. Point A is at 5, 2. So starting at the origin, 5, 2. 1, 2, 3, 4, 5. 1, 2. Here is 5, 2, and this is point A. Now point B is 3, 4. Starting at the origin, 1, 2, 3, and then 1, 2, 3, 4. Here is point B. And then point C, 1, 1. Here is the origin, over 1, up 1. Here is point C. And connecting these together, we have a triangle. That takes care of part A. Now part B, graph its dilation, A prime, B prime, C prime, if the scale factor is 2. Now what a dilation is it is going to be a new triangle. It will be the same shape as our original triangle, but it's going to have a different size. And to find its size, we're going to use a scale factor of 2, which means to multiply by 2. So I can find this new and larger triangle by taking the coordinates that I used to find point A, point B, and point C and multiplying by the scale factor of 2. For instance, if A is at 5, 2, and we transform that by multiplying by 2, that will create a new dot that's called A prime, and that new dot would be at 10, 4. Now on our grid, 10, 4 is, here's the origin, over to 10, and then up to 4, and here's the dot at 10, 4. This is A prime. Now we can do the same technique with point B and point C to find their dilated image. So if point B is at 3, 4 to begin with, and we dilate it using a scale factor of 2, that means to multiply those numbers by 2, that will create a new point called B prime, and its ordered pair will be, 3 times 2 is 6, and 4 times 2 is 8. B prime is at 6, 8. So here is the origin. Let's go to the right to the 6, and then up to the 8, which is right here. And this is B prime. One more to go. Point C. Point C is at 1, 1. And we're going to dilate it using a scale factor of 2. So we're going to multiply by 2. And that will create C prime. And its ordered pair will be, 1 times 2 is 2. And now for its y coordinate, 1 times 2 is 2. C prime is at 2, 2. So here is the origin, 1, 2, and then up, 1, 2. Here's a dot, and this dot is C prime. And we can connect A prime, B prime, and C prime together to create a triangle shape. And we'll notice as we do this that our triangle is similar in shape to the original triangle, but it is larger because all of the distances have been multiplied by a scale factor of 2. So for instance, the side of this triangle, which appears this long in the original, has been multiplied by 2, and then in the new triangle in red ink, it is now twice as long. The same is true for this side. Originally, it is this long, and in the new red triangle, it is twice as long. Every distance has been multiplied by 2. That takes care of part B. Now actually, we've already done part C. Find the coordinates of the dilated image. That is this piece right here, because I had used those coordinates to help me draw that triangle to begin with. So part C is in fact already finished.